Alright, so this video is on Fluke Battery Analyzer. This is the product right here, and this is the BT521 series. And one of the cool things about this product here, if I turn this on, is you can take battery readings and impedance readings in a meter mode or in a sequence mode. So if you're working with a battery string, and I have a demo board just behind this, and I'll show you how you can save those readings in here, and then later you can analyze those readings in the software, which is a part of the tool. There is also a mobile app which you can use, and using this Fluke Connect button, you can actually transfer through the Bluetooth your readings from this tool to the phone app, and then from the phone app you can take a screenshot or share over email. But just this tool here, for the hardware part, beside the screen I have a test lead plugged in here. So this is how the top view looks like. This is 600 volt cat 3 environment, 1000 volt DC max is what it can take. And then the other end of the test leads, it's pretty interesting. These are at the other end of the test leads, and I've removed the cap on this one. So as you can see, it's not a regular connector. It utilizes a 4-wire Kelvin method to actually calculate the impedance of the battery. And what exactly it is doing, if I can focus at this point here, you can see I can actually press this, and then I have this another notch over here. So what I'm simply doing is this part measures the voltage, and this outer part induces 1000 Hz AC signal into the circuit. So now I have my ampere reading, and then I have my voltage reading through this part, and then the meter calculates the resistance. Because you are calculating resistance in milliohms, which your standard multimeter cannot do, and the battery impedance is typically in milliohms, you need a more accurate way to do so. A 4-wire Kelvin method can actually calculate the battery impedance by injecting a 1000 Hz AC signal, which Fluke uses, and then kind of measuring the voltage around that wire, in this case the battery terminals, and then calculate the impedance from there. So you have a AC signal, you have the voltage drop, and then calculate the impedance using the Ohm's law. So this is how the tips look like for both the probes. And now when I come back to the meter itself, so in the meter, I have a meter mode, and then I have a sequence mode. So right now you can see my screen is kind of set up. I have a date and time stamp. I can actually go in setup and then go to general section here, set up my date and time. I can choose what format I need my date and time at. And then this is important because when you're adjusting your date and time, it will show up in your report as well. And when you are plugging those values, it is important to know when you took the reading on the battery string, at what date and what time, because when you go back and take a reading again, you need something for quick comparison, right? So this is something which you can do right here, and I can click on adjust and I can change my date and time. And then there are other methods of you can go and select when the power turns off on the device, 5 minutes, 15 minutes, 30 minutes of doing nothing, or it never turns off. And then the device info, click on serial number, version you are using, factory mode, zero calibration. So this is where I can click on setup and then go on general and have all that ready. There is another function called beep. This is just to turn on the beep mode. So if I now use any function key, it alerts me. Also, when you take a impedance reading using a test leads and press the save function in there, it will alert you. Now when I go back, I have meter mode turned on right now. So beside my setup function, I have meter and sequence, then I have function keys. Right now, if I click on function F1, this will just save the reading I have right now, and my test leads are not measuring anything, so I don't have any voltage reading or I don't have any resistance reading. If I press range, you will see I'm changing the milliohms range. I can do it 330, 300 and 3000. So depending on how many milliohms you are capturing, if you're doing 2200 milliohms, you will put it on 3000 milliohm range. So you have the digits where you can display the 2200 milliohm range. And similarly, you can choose for your voltage DC. It is set on auto range right now, but you can do it a manual range as well. Similarly, if you want to turn on the low pass filter, you will go and press the low pass filter. This turns the low pass filter on. So if you have a very noisy environment, any kind of high frequency signals will get eliminated and only your low pass signals will be let through. So this will allow you to have a much better accurate reading in a very high noisy industrial environment. Then you have this threshold function in F3 where you can actually set up your limits for resistance, and then what your lower limit is, what your high limit is. Also set up a reference, then what kind of warning do you. So let's say if I go and I already did this in, I have couple of those thresholds set up. So my number one threshold is I have a lower voltage of 48 volt. This is just in for a test reference, and then I have reference of 3 milliohm. So anything which crosses 20% of it will be registered as a warning, and then if anything crosses 50% of it of my range will be registered as a fail, and then this will show up in your report as well. And I have not set up any low limit, but you can go and set up a low limit as well, and you can edit this. So you can go and change this. So let's say if I click on this, I can set up a low limit that, hey, the low limit, maybe I don't have a low limit, or maybe I can go and say, you know what, I'm okay with 0.08. And then if I have any notes, what do I want to register this as, I can click and do that. Now I can confirm this and I can go back. So my threshold is set. So if I want to turn off my low pass filter, I'll just press F2 function and I'm back. The other important thing here is the sequence mode. So if you're doing a battery string and you're taking reading on a sequence mode, you set up a sequence mode, you go and press meter, go to the sequence mode. So right now what I'm going to do is I'm going to turn this brief off. So this is off now. So I go back to my sequence mode. So I can create a new profile, or I can choose something which I've already created. So let me create a new profile, create by default, select. So right now it gives me what site are you working at. So I can name the site. So let's say this is a test site. So maybe I'll select this and go here, test, and then maybe I'll do test 1. Okay, click on done. So now my site name is set. Next is device name. So I go and click on device. What am I testing on? So is it a UPS system or anything else? It's just a demo board. So I'm going to select this for our function right now. So go click on demo, click on done. Device ID. Now if you are working with multiple devices, maybe you want to set up a device 1, device 2, device 3, device 4. I'm just leaving it for device 1. How many battery strings are there? So in behind me I have 2 battery strings right here. This is string 1, this is string 2. So I can go ahead and put 2 strings, and I can change this. So click on this F3 here, and this goes to 2. Now battery number. So right now behind me I have 18 batteries on these 2 strings. So maybe I can click on edit and then change this number to 18, and then click on confirm. Battery type, if you have a battery type, lithium ion, nickel cadmium, whatever battery you're working on, you can go and select that. I'm just leaving it blank. And then what is the capacity of a battery, ampere hour. So you can put that here. You can click on edit and change this. So once you click on start, now you get to the home screen. So you will see it kind of numbers. So I have 18 batteries in my 2 strings, and then I'm taking a reading. So it puts the cursor on battery 1. Now when you go and take a reading on battery 1, it will save the reading for your battery 1, your impedance reading and your voltage reading. So let me show how it works. So I'm going to put this right here, and then so what I'm going to do is I already saved the sequence mode. I'll go back, load my sequence. So there it is, load it, and then click on continue. So now it puts that I'm taking a reading, and I'm on right now, it puts the cursor on the battery 1. So here are my terminals. So right now I'm working from battery 1 to 9. There are 2 strings on it, and I'm not measuring discharge voltage. So I've not put a load on the batteries, which I can simulate using this cursor right here. But what I'm trying to do is just simply take a impedance reading and take a voltage reading. So I have that in my screen right here, and then I go ahead and click. So you see, as I take the reading, it fails and it saves that reading. If I click on save, it saves that reading. Click on threshold. I have a threshold that my low limit should be 0.08, and then my higher limit should be reference is 3 milliohm. So right now I'm set on sequence mode. I've loaded my profile. This puts the cursor on my battery 1. The range is set for 3000 milliohms, and then the volt DC is auto ranged. There is no threshold. I haven't set any threshold. I mean, I can go and set a threshold of a pass and fail limit, but I haven't set any threshold because I'm just doing this for a test purpose. So what I do is I'll go ahead and take a reading. So as it takes it, and when I remove the test leads from here, it kind of moves on to the second battery on the screen. Then I go again to the second battery, take a reading here, takes the reading, saves it, goes to the third one, take a reading to the third one, saves it. So now, and as much, so I can go back, I can take this reading again. If I feel that I haven't taken a good reading, I can erase this reading and I can take this reading again. But now it will go on till your 13 battery, 18 battery, and it also gives you what is the average of the total impedance you have taken. And if you're doing strap resistance in between two batteries, you can click on strap and then take the strap resistance. But since I'm doing batteries, I'm just putting it on battery here, and then this is already saved. So now I have a USB stick. I can connect my USB cable and open this in the management software, in the battery management, and I can open this in the battery management software, which I'll show you in the next video. But with this right now, let me put this on discharge voltage. So if I'm capturing discharge voltage now, so I turn on the discharge. So now I have kind of induced a load to my circuit, so the battery is discharging, and what I should see is my voltage should decrease than the previous voltage. First reading, go to the second. So because now you're calculating voltage when the battery is in use, the voltage will decrease until the battery runs out. And for different kind of batteries, for a lithium ion battery or a nickel cadmium battery, the discharge voltage curve will be different based on the characteristics of the battery. The discharge voltage curve will be different, and now you can take those readings. Now these are also saved, and then you can go on to the next and leave it here. The other thing I can do here is click on this Fluke Connect button. So it puts a Fluke Connect function on my phone, and then use my test phone, download this Fluke Connect app on my phone. So the app name is Fluke Battery Analyzer Mobile. Download this app and then click on this Fluke Connect function here. So this turns the Fluke Connect function on, and then I open the app here on my device, and then I'm trying to connect this to my phone right here. So now this device shows up in my phone. Okay, so now I can see I'm connected to my device right here, and then I can see all the data on my phone. The device says that it's ready and it's connected to the phone now, or to the phone app. Allows to focus here. So if I click on any of the data I've taken, I can see that I have all the data. I click on more data, and then it kind of shows me my impedance value, discharge voltage, volt DC, volt AC, ripple, and aux if I want to measure any current. If I expand this, you can see all the resistance value, and it kind of puts it in a very nice tabular form. From here I can take screenshots. I can also click on email message and then kind of send a message if I want that, but this kind of puts it in a very nice compressed form, and it's good that you can put it on your phone as well. So when you're taking reading on your device and then you want to quickly view it and send it over to someone, you can use your phone and have this app ready and take a screenshot and then send it to take a snapshot and then send it over. So this nice feature is pretty good, and then later we'll see how this connects to your battery management system software, how this connects to the battery management software, and then we'll do some analysis there. But I hope this was helpful. Thanks for watching.